Let us start. Today we will be discussing regarding muff coupling. This is the question regarding muff coupling. It will be called as rigid sleeve coupling also. It will be called as rigid sleeve coupling also. If you see the question, in the question it was given that you have to draw the diagram, make a neat sketch. If not, dimension the sketch, make a neat sketch and dimension the sketch. That means you have to draw the diagram and you have to give dimensions of that diagram also. This is nothing but sleeve or muff coupling. Sleeve or muff coupling, sleeve or muff coupling. Already muff coupling I have given over here. Okay, and it is connected to transmit 28.5 kilowatts of power at 1200 rpm. Here power has been provided, that is power is equal to 28.5 kilowatts, and also rotations rpm, n value we will represent it as n value. N value is also given as 1200 rpm. The material is 25% overload. That means here torque maximum is equal to 1.20 into torque mean. Whatever the torque with the power and with the rpm we will get, it is a mean torque, but we have to find out the maximum torque. That is 20% overloaded. 20% overloaded is nothing but 100 plus 20 by 100, which will make 1.2. Okay, that means it is 20% overloaded. The material for the shaft and key is of plain carbon, that is they are made up of same material, which is having allowable shear and crushing stresses. Here allowable shear stress of the shaft is equal to allowable shear stress of the key is equal to 75 megapascal. It was given that, see, shaft and key material, both shaft and key material are made up of carbon steel. So that I have considered allowable shear stress for shaft and key is equal to 75 megapascal. And also allowable crushing stress, sigma C for shaft is equal to sigma C for key is equal to 140 megapascal. 140 megapascal. Okay, the material for the muff is made up of cast iron. Okay, the material for the muff is made up of cast iron. That means muff material, here we are having only three parts, three components. One is a sleeve, one is shaft, the other one is key, the last one is muff. Thereby here, as it is given as shear stress for the cast iron C, tau C is equal to 18 megapascal. See, if you see the diagram, in the diagram, there are only three parts. The first part is shaft. Here it is. Second part is key. Third part is muff. If you find out the parameters of these three, if you find out the parameters of these three, for shaft, you have to find out the diameter D, small d. Similarly, for key, you have to find out the length. Okay, length, thickness, and width also. Here, length, thickness, width we will assume as per the dimension of the shaft. Okay, that I will tell you anyway. Next, muff. Here you have to find out the diameter of the muff, that is capital D. These are the parameters that you have to find out. That you have to find out. That is D, L, and capital D. D is the diameter of the shaft. L is length of the shaft, and length of the shaft or length of the muff. And if not, length of the key also you can consider. And D is the diameter of the muff. T and W are thickness and width of the key. Anyway, these two values we will assume. Thick and width we will assume. Okay, let us try to solve this problem. First one is that anywhere. First one is that we have to go for design of shaft. In order to design a shaft, we need torque. The thing is that first we have to find out the torque. Okay, then only we can design the shaft. For finding torque, for finding torque with the given variables. Given variables is nothing but power and also RPM, that is rotations per minute. The given is that power and rotations per minute. By using these two, we have to design our shaft. The formula for finding torque by using power and RPM is torque is equal to 2 pi nt by 60. Power is equal to 2 pi nt by 60. This is not torque, this is power. Power is equal to 2 pi nt by 60. In this formula, we have power, we have RPM. The thing is that we have to find out T value. Okay, whatever the value you get torque, that is mean torque. Mean torque is nothing but average torque. Average torque is equal to 60p by 2 pi n. Okay, just substitute the values over here so that you will be getting your answer. Substitute the values, that is 60 into p value is nothing but 28.5 by 2 into pi into n is nothing but 1200. N is nothing but 1200. Okay, just find out this answer. You will get your value, mean torque. That is torque mean. If you calculate, you will get answer as 226.7 into 10 to the power of 3. Okay, the value you will be getting in Newton meter. You have to convert this value into Newton millimeter, so that into 10 to the power of 3. I have multiplied into 10 to the power of 3 so that it has been converted into Newton millimeter. Okay, now I want to find maximum torque, not mean torque. Thereby torque maximum, if not I will change the color. Torque maximum is equal to 1.2 into torque mean. That is 1.2 into 226.7 into 10 to the power of 3. Okay, thereby you will be getting torque maximum is equal to 283. The calculated value will be 283 into 10 to the power of 3 Newton millimeter. This is our torque value. I got torque value. Thereby I can find out diameter of the shaft very easily. That is the formula is torque is equal to pi by 16 d cube into shear stress. As we are discussing regarding shaft, this is shear stress of the shaft. As we are discussing about the shaft, that is shear stress of the shaft. Thereby we know what is torque value. This is torque maximum value you have to consider. We don't know what is d value. D value we have to find out. Shear stress value. The thing is that you have to find out d cube value. D cube value is equal to 16t by pi into shear stress for the shaft. Shear stress for the shaft. That is D is equal to cube root of 16 into torque value. We have already know the torque value. Found out the torque value. We have already found out the torque value. That is 283 into 10 to the power of 3 by pi into shear stress. Shear stress in the question it was provided as 75 megapascal. If you find out the answer, you will get D is equal to 30 millimeter. D is equal to 30 millimeter. Okay, this is your answer. After finding D value, we have to find capital D and also length values. That is length of the muff L and also capital D, that is diameter of the muff couple. For this, we have a relation. As per the design data book, we have a relation, that is 3.5 into D is nothing but L. 3.5 into D is nothing but L, and capital D is nothing but 2D plus 13 millimeters. This is from design data book. That is length is equal to 3.5 into D. Capital D is equal to 2D plus 13 millimeters. Now you will find the answer for this, and in the next formulas we will verify these answers. Okay, That is L is equal to 3.5 into capital D. Capital D, small d is nothing but 30 millimeter. Okay, that is you will get length is equal to 105 millimeter. Length is equal to 105 millimeter. Similarly, D value is equal to 2 into 30 millimeter plus 30. It is D is equal to 73 millimeter. See, the thing is that we have to find out only three variables. In that, first variable is small d, second variable is capital L, and the third variable is capital D. Strictly speaking, our answer is completed. Strictly speaking, our answer is completed. But we have to verify whether we got our answers correct or wrong. We have to verify whether we got our answers correct or wrong. So that we are going to verify our answers. I am strictly telling you that we are going to verify our answers. Sorry, we are going to verify our answers. That is, see here I am writing the three values. L is equal, capital small d is equal to 30 millimeters, L is equal to 105 millimeters, and also capital D is equal to 73 millimeters. I am going to verify these three values. I am going to verify these three values, verification. Okay, whether these will satisfy the design conditions of the shaft or not. Okay, for that, here we will be going for verification. Okay, strictly speaking, here we have completed our answer, but we are going to verify our answer. Verification. For verification, just a minute. Okay, let us continue. For verification, we have a formula. T is equal to, this is regarding the design of the couple. This is nothing but regarding the design of the couple. In the notebook, we have written it. We have written this case as formula number 2 or step number 2 as design of sleeve or muff or hub. Okay, we have written in this way: design of sleeve or muff or hub. Design of sleeve or muff or hub. We have written in this way. Okay, now for this we have a formula, that is torque is equal to pi by 16 capital D power 4 minus small d power 4 by capital D into shear stress of the couple or sleeve or muff or hub. Okay, this is regarding shear stress of the sleeve or muff or hub. Okay, this is now regarding the shaft. Okay, I have already derived this formula in the classroom or in your notebooks. You can verify from there. Here, in this formula, we know what is tau value, we know what is capital D value, we know what is small d value, and even we know what is shear stress value also. But we know this value, but as it is a verification, we have to find this value. Okay, we know this value as per the question, but as it is a verification, we have to find out shear stress only. That is, shear stress is equal to 16T by 4 minus D power 4 into pi. D power 4 minus D power 4 into pi. Okay, now just substitute the values. That is, shear stress is equal to 16 into torque value. Torque value I think we have got as 283 into 10 to the power of 3 by D power 4. D power 4 is nothing but 73 power 4 minus 30 power 4 by 30 into into pi value. If you solve this answer, you will get shear stress is equal to 3.82 Newton per millimeter square. But in the question, it was given as 18 Newton per millimeter square. Thereby, it is far less than the value that is being provided in the question. Far less than the value that is being provided in the question. So that I will write here, hence our design is safe. Hence, our design is safe. Hence our design is hence our design is safe. Design is safe. Okay, how did I came to conclusion of this statement is that because shear stress of the couple is far less than shear stress of the couple that is being provided in the question, so that I have came into this conclusion. Okay, and next, this is regarding second one. Similarly, we have step number 3 also. This is design of key. This is design of key. Okay, as per the dimensions, as diameter of the shaft is equal to 30 millimeter. As the diameter of the shaft is equal to 30 millimeter, so we have to assume, because diameter of the diameter is 30 millimeter, we have to assume width of the key is equal to 10 millimeter, thickness of the key is equal to 8 millimeter. I already told you, if diameter is equal to 30 millimeter, if diameter is equal to 30 millimeter, okay, you have to assume width is equal to 10 millimeter, thickness is equal to 8 millimeter. If diameter is equal to 70 millimeter, width should be equal to 20 millimeter, thickness should be equal to 16 millimeter, It goes on. Something like this. Okay, these two variables will be sufficient. Okay, anyway, come to the question here. For designing a key, we are having two formulas, that is torque is equal to length, if not capital L by 2. Okay, length of the key is nothing but half of the length of the length. Okay, L by 2 into W into shear stress of the key into diameter by 2. Okay, similarly, one more formula we are having, that is L is equal to, that is length by 2 is equal to T by 2 is equal to sigma Ck into D by 2. Okay, these values we have to find out. Here in this we have torque, we have length, we have width. Okay, even we know what is shear stress of the key, but we are not going to find out the shear. We are going to find out shear stress of the key only. We know this, but we are going to find out this. We know the diameter. In this formula also, we know what is torque, we know what is L, we know what is T. Okay, we know what is diameter, even we know what is crushing stress. Still we are going to find out the crushing stress. Okay, that is shear stress of the key is equal to T by L by 2 into W into D by 2. Similarly, crushing stress of the key is equal to T by L by 2 into T by 2 into D by 2. Just substitute the values. That is, torque is equal to 283 into 10 to the power of 3 by L by 2 is nothing but 105 by 2 into width is 10, diameter is 30 by 2. Similarly, here also 283 into 10 to the power of 3 by L by 2. L by 2 is 105 by 2 into 8 by 2 into diameter by 2, that is 30 by 2. Just now find out your answers. That is shear stress of the key is equal to 36 Newton per millimeter square, and also crushing stress of the key is equal to 90 Newton per millimeter square. This should be less than, if I am not wrong, 75. This should be less than 75. This should be less than 140. Okay, as these are less than those values, hence our design is safe. Hence our design is safe. Okay, any doubts up to here? Anyone? This is regarding our Muff couple. Similarly, you will be having split muff couple also in the same way. You will be having split muff couple also in the same way. You will be having split muff couple also in the same way. Okay, any doubts up to here?
No, sir.
Okay, anyway, I will